The way we're going to start this next unit is today we're just going to look at the top few examples of finding vertical asymptotes of a rational function. You already kind of have the intuitive feel for this because of what we did previously. So where on our basic graphs, those two graphs we just dealt with, where on the basic graphs do the vertical asymptotes occur? When what's zero? No, not quite. Not the x and the y. What part of my rational function is zero? What did we plug in that gave me an undefined outcome? Zero. Okay, so my vertical asymptote happens when my denominator is zero. So this is what I just want to mention to us. The vertical asymptote occurs, I never remember if there's one C or two in occurs, so it might be spelled wrong. Vertical asymptote occurs when the denominator is zero. This is the key. When we come back on Wednesday, we are going to have a process to graph these more complicated rational functions. The first step is going to be to find the vertical asymptote, because remember, can a graph ever go through a vertical asymptote? No, it cannot. So that's important information to have. So for instance, the first example is this. F of x is equal to x minus 1 over x plus 4. I want to find the vertical asymptote of this. Well, I have just told you that the vertical asymptote occurs when the denominator equals 0. So here's the process. All you ever do when you're asked what the vertical asymptote of a rational function is you scoop away the denominator. And you say, okay, when is that equal to 0? What input do I put in here that gives me 0 in the denominator? Now, you could probably solve this mentally, but all I'm going to do here is I'm going to subtract the 4 from both sides. And that tells me that when the x value is negative 4. And the convenient thing is, that's the line. X equals negative 4. That's the equation of the vertical line. So you've already got it in the form that I want it, which is the line that represents the vertical asymptote. So there you go. There's the answer to the first one. So I think we graphed that one, and we will next time. So the first bit of information we have is that I can draw a dotted vertical line at x is negative 4, and I know the graph's never going to go through that. What I would like you to do, please, is the next example that's just to the right. Very similar. It should not be too taxing, I'm hoping. All right, once again, I'm asking what the vertical asymptote is, so hopefully the one takeaway you'll have from this, this little bit of the unit we've done is that happens when the denominator is equal to 0. I add 3 to both sides, and that tells me what is the equation of the vertical asymptote. X equals 3. The x equals is important, okay, because that tells me it's a vertical line. If you just say 3, I have no idea what you're talking about. Okay, is it y equal to 3, x equal to 3? What? So tell me x equal to 3. Do the next one. We've got one that has a quadratic in the bottom. So we get to review something that was on the test you just took. Very exciting. All right, just to help you through this one, because it's going to help us with the last two examples. So this, in the denominator, I have a quadratic. How do I know? The x squared. So this one's factorable, but if you wanted to use the quadratic formula, that always works every time, every day, no matter what. But I'm going to factor this because it's a little quicker. X squared is x and x. The two factors of -6 that add up to -1 are -3 and +2. So you might be thinking, well, Mr. Perkins, can I have two vertical asymptotes? And the answer is, oh yeah. Oh yeah, that's going to be fun when we graph it. We're going to have a great time when we come back on Wednesday. So the first vertical asymptote is going to be the line x equals 3. So when I go to graph this, I'll do a nice dotted line at the x value -3. And then I'll do the same thing at the x value -2. There are two vertical asymptotes to that graph. So with that knowledge, maybe you didn't know there could be two and you were stuck. That's totally fine. Before you do the next one, we've got two problems left. When I'm dealing with the vertical asymptote, have I addressed the numerator at all? No, it does not affect the vertical asymptote, so don't be distracted. So do the next problem, please. So I'm going to take my denominator, x squared minus 16, set that equal to 0. Again, you could use the quadratic formula. You could add the 16 over and take the square root of both sides. I'm just going to factor x squared is x and x. The two factors of -16 that give me a middle term of 0, since there's no middle term, are +4 and -4, if you remember your difference of squares from intermediate algebra. And so then I've got x plus 4 equals 0, x minus 4 equals 0. So once again, there are two vertical asymptotes, perfectly legal. So the first one is at x equal -4. The other one is at x equals +4, two vertical asymptotes. So I'm going to give you about 90 seconds. This will factor, hint, hint, if you want to give it a try, our last vertical asymptote problem. All right, so last problem, the denominator, that's where the vertical asymptotes always happen, is where the denominator is equal to 0, where I would get something undefined as my output. So again, the quadratic formula will definitely work here. X squared is x and x. The two factors of negative 24 that add up to negative 5 are negative 8 and plus 3. So once again, we're going to end up with two vertical asymptotes. The first one is x equals 8. The second one is x equals negative 3. So that will be our first step when we go to graph these more complicated rational functions. And that is where we will end today's section 5.2.